In this lesson, we are going to be looking at how you write numbers in scientific notation and then converting them back and forth from standard notation to scientific notation. Scientific notation is a way that we write either really big or really small numbers so that we don't have to write a whole bunch of zeros when we write a number, because that can be hard to read. So when we see the number 3,450,000, we might write it in scientific notation. Just to remember that when you write things in scientific notation, you need to have one number to the left of the decimal. That would be the 3 in this case. That number can't be a 0 and it can't be a 10. So it has to be a 1, 2, 3, 4, 5, 6, 7, 8, or 9. Okay? You can't have a 0 to the left of the decimal, and you can't have a double digit or higher number to the left of the decimal. So you need to have a single digit number, and then you put the decimal where it needs to go. So in this case, my decimal was right here, and then to the right of the decimal I had 1, 2, 3, 4, 5, 6 places, and so that's why it says times 10 to the 6th. So here I've given you a number that's already in scientific notation, and you are going to give it to me in standard notation. So when the exponent is positive, like it is right here, basically what that means is you need to take the decimal and you need to move it this many, 5 in this case, places to the right. So I would need to go 1, 2, 3, 4, 5. Well, I don't have a number in this spot or this spot or this spot, so I would fill those in with zeros. Okay, so I have the 2 that's here, the 1, the 9, and then a 0, a 0, a 0 right here. And that would be your number in standard notation. Okay. If you have a negative exponent, like I do right here, that means you're going to need to move the decimal to the left. So with negative exponents, you would move it to the left. And so I would go 1, 2, 3, 4, 5. And I know I'm running out of space here. I've got the 3 filled in here, but these would need to be 0, 0, 0, 0. Okay? And my decimal, of course, would end up right there. So I would have point, 1, 2, 3, 4 zeros, and then 3, 2. And that's what that would look like in standard notation. If we go the other way around, you see a really big number in this case. And again, you need to have one single number to the left of the decimal. So you're going to find the number that is not a 0. In this case, that's the 3. I would put my decimal right here in scientific notation so that I have a single digit to the left of the decimal. And then to the right of that decimal, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 spaces. So this would actually be 3.022. You can ignore all the zeros after that. So I'm looking at kind of this big chunk right here. But still, to the right of the decimal, I have 12 spaces. So this would be times 10 to the 12th. Positive 12, since my numbers are to the right of the decimal. And here I would want to find that one single digit and then some numbers after to put my decimal. So my decimal would go right there. Here's my single digit. And then to the left of that decimal, I have numbers mostly now to the left of that decimal. So I would have 4.53. Here's my solid number I'm looking at. And then in scientific notation, I would move that decimal 1, 2, 3, 4 places to the left to get where it is. And so this would be times 10 to the negative 4 since I moved it to the left.